All right. Hello, beautiful people. I am out because of my COVID booster shot and flu shot, 2 in 1. So today I am going to go over Newton's laws, just the first law. So in your packets, please turn to page 14, where it looks like, whoops. Okay. It's not showing on my screen here, but here's what it looks like in your packets. Go to page 14. There we go. And you should have a utensil, pen, or pencil to fill in the blanks and take notes as we learn about the law of inertia right here. So Newton's first law of motion is known as the law of inertia. Inertia is your vocab term. Inertia, if you've ever watched Bill Nye, inertia is a property of matter. It's in the intro to the video, and so you might remember that. And there are 3 of Newton's laws, and inertia just means that all objects have inertia. I call it the lazy law. When you have a lot of inertia, you don't want to change your motion. You're lazy. Like in the morning, I have a lot of inertia. I don't want to get out of bed. And the first law says, an object at rest will stay at rest, and an object in motion stays in motion unless acted on by an unbalanced force. So I'm going to stay in my chair unless somebody rolls me off. If I'm out in space, right, blasting off towards Mars, I'm going to continue on that path because there's no unbalanced force, aka air resistance, to slow me down. Here on Earth, we've got a lot of unbalanced forces to change our motion. So part 1, an object won't start moving unless an unbalanced force, a push or a pull, is exerted on it. So looking at this picture here, the golf ball is going to stay at rest unless an unbalanced force is applied to it. That could be the golf club. It could be wind blowing it off the tee. That's air resistance, right? So it's just going to stay there. Those are the laws of nature. I like to call them our common sense laws because we see these things every single day, right? Part 2 is even moving objects have inertia. It moves at a certain velocity, remember speed with direction, and will continue to move in that same direction and speed unless an unbalanced force acts on it. You throw a baseball, it's going to keep on moving until the catcher catches it, until air resistance, an unbalanced force, slows it down. If it hits the ground, that's an unbalanced force that changes its movement. That's Newton's first law. Object at rest stays at rest, and an object in motion stays in motion unless acted on by an unbalanced force. So you have a soccer ball. According to Newton's first law, it's going to keep rolling at the same speed in the same direction unless an unbalanced force acts on it. And that could be the friction from the floor or the grass or the wind or the air that gets in the way. And eventually it stops, right? If we were in space, if we were in a vacuum, that soccer ball would just go on forever and ever and ever unless it hit something. Now, inertia depends on 2 things, okay? So we also call Newton's first law the law of inertia. It is the tendency to resist a change. Remember, it's the lazy law. I want to resist getting out of bed. I have a lot of inertia. So part 1, objects at rest stay at rest. Part 2, objects in motion stay in motion. And inertia is the reason why it's impossible for things to stop instantaneously. Inertia depends on 2 things. So actually 1 thing, it's mass, which is how much stuff something is made up of. And mass also determines if it's heavy or lightweight. Smaller mass is less inertia. Larger mass, more inertia. So it's easier to push a miniature car to get it in motion than a school bus, right? If you're at a stoplight, it takes a long time for those big truckers to start moving again because it has a lot of mass and therefore a lot of inertia. Conversely, it is harder to stop objects with a lot of mass. It is harder to stop a bus, right? You need ample distance, stopping distance. Otherwise, it's going to crash. And it's also harder to stop it's easier to stop a smaller object. So if you were to stop a bowling ball coming at you versus a tennis ball is much easier because it has less mass, vocab term, and because it has less inertia, okay? And conversely, it's also harder to get these things to start moving, okay? Inertia is the reason why you wear a seatbelt. Remember, objects in motion stay at motion. If you are riding on top of a car in a truck bed, your truck is going 30 miles per hour and it stops, it hits a rock. You think your body that's not connected to that truck bed is going to stop automatically? No, because of Newton's first law. An object in motion, you're going to continue going at 30 miles per hour unless an unbalanced force stops you, unless you hit something, the ground, a house, a tree. And so that's why we wear seatbelts. It's because of inertia. Now your substitute teacher is going to play the science of the NFL, Newton's first law in action. Watch and learn. And then when you're done with that, you are going to complete something called the Webquest. Let me show you what that looks like here. Here is the Webquest. It's on Newton's first law and asteroid defense. So you can work with a partner or work alone, and then answer the questions to complete it. And when you're done with that, follow the instructions to finish, your gizmo, your scientist Canva, all of that good stuff, or the math challenge, right? Or you have quiet free time. I hope that this lesson was helpful. And when I return, we're going to test your knowledge on inertia on Monday. And you're going to share out about the trans and indigenous scientists that each of your team members read about. I hope you have a restful weekend. I'll see you all on Monday. Let's hope so. I really want this baby to keep on cooking.